Hey everybody, and welcome to Breaking Biotech, the podcast where we get into all things biotech trading. I've got my biotech portfolio and trying to beat the market with it. So today I want to talk about that, update on that, and I also want to talk about the Avexis Novartis merger that just happened, was announced earlier in the week, which is pretty cool because I currently have a stake in a different gene therapy company. So I'm going to talk a little bit about gene therapy, talk about Avexis and Spark. Before I get into it, I want to thank everybody for coming in and watching. Really appreciate it. And if you could like, subscribe, or leave a comment, that would be great. None of the information I'm giving is trading advice or investment advice. You have to do your own research for that. But let's get into it. So I did not get a chance to do a video last week, and it wasn't because the market was terrible, at least for me anyway. I was down 11%, but this week climbed back quite a bit. So went from 11% down on the 8th to where I'm at now is negative 2.2, and compared to the total biotech ETF, I'm doing quite a bit worse. So tread carefully if you're going to take any of my suggestions. So the biotech XBI is up 5% for the year, and the SPX is almost even, actually, just under 1% down. So I'm happy that this week went actually a lot better because negative 11% really makes you question your strategy here. But the things that are keeping me afloat is my Illumina investment, as well as Spark. And Fate's doing okay, but they've been bouncing around a lot between 9 and 12. So before I get into Novartis, Avexis, and everything, also, so volatility, we're actually expecting a decrease in volatility this week. So the expected move last week for the XBI was almost 5%, and we actually exceeded that. So the move was going to be about 4 points, and we ended up at 89.58. So I think the markets are struggling a little bit to price the volatility that we have going on, but this week it should be a little bit lower, so keep an eye on that. Okay, so I have a small position in Spark because they are a gene therapy company, much like Avexis. So for those who don't know, Avexis' stock pretty much doubled in price once Novartis announced that they were going to pay $218 per share, essentially just about doubling their market value. They're going to become one company, and it's going to be interesting to see how this goes on. So this is the press release. Basically $8.7 billion, and they get all of their employees and their technology. So it shows that this sort of gene therapy has a lot of potential. I think a lot of companies see this as being potentially very lucrative investment. And gene therapy has been around for a couple decades now, and it initially had a lot of trouble getting out the gate because there were so many issues with things like ability to control the amount of protein that gets added. So maybe I'll do a primer on gene therapy. So basically, a lot of these diseases, so Avexis is, what they're looking at is, it's called spinal muscular atrophy, SMA, that's their main product, Rett syndrome and ALS, genetic ALS. So these are all diseases where there's a mutation in the gene, and that mutation leads to a non-functional protein or an overfunctional protein, and we can use genetic techniques to interfere with that gene by either producing some good copy of the gene by adding that sequence of DNA to the cells in the body somehow, and there's different vectors that can do that, or there's technology known as RNA interference technology that Avexis is also getting into. So you transfer this RNA interference technology that's able to knock down the expression of a gene that has a mutation, but it's being produced, so you don't want it there. So this is how it works. So basically, this AAV9 capsid shell, so this is a human virus that infects human cells, and it's been genetically modified to contain some sort of transgene, and this transgene, in the case of SMA treatment, is the correct form of so the SMN1 gene, which is the one that's mutated in this disease. I won't get into too much detail about the disease itself, but suffice to say it's a very detrimental disease, spinal muscular atrophy. Basically, kids don't live very long with it. and they have a lot of trouble swallowing and breathing, and they have muscle problems due to loss of motor neurons, and they get muscle wasting. So it's very sad to see, and it's a genetic problem. So there's some sort of mutation that happens in the process of the zygote being formed, and you're stuck with this disease. So what Avexis tried to do, and successfully has done, is they have taken advantage of this AAV9 technology, which is a virus, like I said. They've added the human SMN transgene. They've put it in this vector, and they've infused it into babies. So once they get diagnosed, they infuse this drug, and in hopes of trying to reestablish the correct amount of SMN1 gene through this promoter that has a certain amount of activity. So this little cartoon that Avexis has makes it very easy to understand. So normal people have SMN1 and SMN2 that's produced properly, and you have no problem. But if you have SMA, there's a problem with the SMN1 gene, and so you don't get this protein, and so you're only stuck with SMN2, which isn't ideal. So what Avexis is trying to do is increase the amount of SMN1 by infusing this AAV9 vector that contains the SMN1 gene. So that's how this technology works, and it's a similar thing with Spark. The only difference, it seems like, is that instead of AAV9, Spark uses an AAV vector. So it doesn't really matter as long as it works. So a lot of the problems that happen with gene therapy is that the vector wasn't very good. So you wouldn't get a good enough transfection, or there'd be toxicity associated with the vector. So this vector seems to have low toxicity, and they have a good amount of transgene transcription and translation, so you get a lot of protein product at the end. Yeah, so Avexis has been pretty successful with this. I won't get into too much of their data because they have a lot of data, but basically they've given multiple children this viral vector, and they see a significant increase in the amount of lifespan, in the amount of other outcomes associated with it. So they can swallow, they can breathe on their own, which is a problem. So they've had a big impact on these kids' lives, and it's only one infusion. So I think something that's going to be tough to get down is the dosing. So you're putting in this transgene, and we don't know how much activity it's really going to have. So they've given 2 different doses here, and the kids with the higher dose do much better. They last a lot longer in terms of event-free survival. So this might be what goes on later, but I think the attractiveness of this that Novartis sees is that it's the system. Avexis is also doing work with ALS and Rett syndrome. So the ALS thing is a little different because they're using a knockdown technology. I won't go looking for it, but basically it's an RNA that binds to the native SOD1 RNA to make it not translate into a malign protein that's affected in ALS. So basically a lot of these genetic diseases are going to be able to get a vector made for it, and so there's a lot of potential in a ton of genetic diseases if this technology continues to work. I'm sad that I didn't jump on the Avexis train, and I know Martin Shkreli was a big proponent of Avexis, and this was one of his real successful calls, it seems like. So got to give props where props are due, and sadly Shkreli will be enjoying his gains behind bars, but I think he's also talked about Spark as well. So what I think is interesting about this whole thing is that there's obviously a lot of interest in this. So so Spark went up quite a bit on this news, so down from 62 to 77. So part of me is thinking that there are other companies that, well, Novartis, Pfizer, there's a lot of other companies that might want to buy out other early stage gene therapy companies. So I haven't increased my position in Spark, but I think there's a lot of potential here. So Spark has had a successful gene therapy called Luxturna, and that is for a specific kind of blindness. RPE65 mutation leads to blindness, so they've been able to reintroduce that gene by doing an intraorbital injection with their specific gene therapy, and it works. So it's relatively expensive, but they're curing people from blindness, which is very interesting. And the rights outside the U.S. have been licensed to Novartis. So Novartis is clearly looking to get into the gene therapy space, which is interesting. The other things that Spark is looking at is hemophilia A and B. So hemophilia is a bleeding disorder, and there's different types based on what sort of factor you're missing. But based on that, you can decide to introduce a transgene that'll just replace that factor instead of using the current technologies, which make it hard. So they've shown very good data so far involving hemophilia, and they have two different infusions here, the SPK9001 and 8011 for the different phases. So, we'll see how those go. There's a lot of competitors involved in the hemophilia space with that. So I think that's what led to the drop in Spark's price about 3 or 4 months ago. They dropped in some news that one of the other competitors had a better effect, a more controlled dose. So again, with these gene therapies, it's hard to control the amount of expression of this proper protein. And in hemophilia, you worry about that because if you get too much of a clotting factor, you'd be at risk for stroke or heart attack if you clot too easily. So there's this balance that you need, and it'll be some growing pains in the field. But I think also with this company, if they can get a viral vector that's very attractive, they can use it for a bunch of different diseases. So they're interested in this POMP disease, a liver disease, as well as another eye disease. So clearly they're good in the eyes. So chorioideremia, they're doing their vector with a different protein or a different gene, and they're looking at that. So I think these companies are going to become very, very interesting as we move forward, since the technology seems to work. And it's nice to see that, because gene therapy, we do it in the lab a lot, just transfecting cells with some sort of construct to either to overproduce a protein or to knock it down. So to see us being able to do it in humans, I think is pretty interesting. That's all I want to talk about today. So I guess a bit of a shorter video, but I want to thank everybody for watching. Please like, subscribe, leave me a comment, and let me know what you think. If you have any tips or anything, any companies that you want me to look at, please let me know. And with that, I'm going to wrap it up.